Hello everyone. Today I'm going to answer problem number 9, the one that we were working on Thursday this week. And the problem is related to the chapter solutions. And that was involving stoichiometry. That's why I want to share with you my answer on this one. Again, this is for chapter solutions. And let's start by rewriting the equation. They say on the problem, potassium iodide react with lead to nitrate in the following precipitation reaction. And what is the minimum volume of 0.2 molar potassium iodide solution is required to complete precipitate all the lead in 155 milliliter of 1.12 molar of lead nitrate. There is a lot of work on the problem, but I will try to simplify as much as I can. So here is the first thing to rewrite the equation. So you have the potassium iodide in solution reacting with the lead 2 nitrate. That will be the next reactant. And the reaction will produce potassium nitrate, 2 mole of potassium nitrate in solution. And also it will produce a precipitate that will be lead 2 iodide. It's a solid that will precipitate. If you check the equation, it's already balanced: 2 potassium on the right, 2 iodide, 2 on the right, 1 lead on the right, 2 nitrate. This 2 in front of the potassium nitrate is multiplying the nitrate. So the next thing that I'm going to do is placing all this number on the equation. The first thing they gave us is the potassium iodide solution, the concentration. The concentration of potassium iodide is 0.200 molar, and that's my first thing that I'm going to answer. And they ask you what is the minimum volume. So that will be finding the volume of this solution, how much you need to make to react with a concentration of 0.112 molar of lead 2 nitrate, and they gave you the volume of lead nitrate. That will be 155.0 milliliter. That will be all the data or number gave you in the equation. If you notice, 2 mole of potassium iodide will react with 1 mole of lead 2 nitrate. So the ratio is 2 to 1. If we find the number of mole of this reactant here, we can use the molarity formula for solving how many milliliter or liter of volume of potassium iodide solution we need to neutralize. So the first thing is finding using the molarity form. Molarity will be the number of mole of any X substance over volume. And here they gave you the molarity already, 0.112. Don't forget the molarity is mole over liter or capital N. You can represent by capital N. We need to find how many mole of lead nitrate to lead 2 nitrate. We have in 155 milliliter. We need to convert the 155 milliliter to liter, and that will be by dividing by 1,000, and the answer will be 0.155 milliliter of solution. Why I have to liter? Let me raise that will be liter of solution. Why we need to divide and convert to liter? Because the uniform molarity is mole per liter, and that's why you have to convert milliliter to liter. So the denominator here will be 0.155 liter. That will be the denominator. So the number of mole of lead 2 nitrate will be equal to 0.112 mole liter be multiplied by 0.155 liter. Liter and liter cancel out, and the multiplication that I go is, let me redo that again, that will be 0.112 times 0.55 will be, my answer on this one was 0.0173 mole. That will be my answer on this one. Next will be, if I know that this is the ratio, I need to find, I know already the mole of lead 2 nitrate that we have on that equation, so I need to place this number here, 1.73, and finding how many mole of potassium iodide I need. So mole of potassium iodide that I will need is 2 times 0.0173. And that multiplication, the value for that multiplication was X, or number of mole, will be 0.0347 mole. That was the mole of potassium iodide that I need. Molarity of potassium iodide will be equal to number of mole of potassium iodide over the volume of solution. And they asked me on the problem to find volume. So volume will be equal to the number of mole of potassium iodide over the molarity of potassium iodide. Number of mole, I already found this one here, 0.0347 mole, and divide by the molarity given. That will be 0.200, and that will be dividing these two. Let me do the calculation again. Divide by 0.2. This is my answer on this one. I go 0.1736, and this is liter. Why liter? Because the molarity, as you know, is this one is mole over liter, mole cancel out with mole, and that's the unit at the end. But the answer, as you can see here, the closest one is 174 milliliter. Why we need to convert this to milliliter in order to match that answer? So this one multiplied by 1,000, because if you, let me write on the side here, 1 milliliter equal 0.001 liter, or 1 liter equal 1,000 milliliter. So if we multiply this one by 1,000, that will be equal to 173.6 milliliter, and the correct answer by rounding 173.6 will be this one. So that will be the correct answer, and you can check that by going to your textbook under the chapter solution and check problem number 9. Thank you for watching, and this is for today.